Module 3, Lesson 2, Student Page 11. Consider a sequence given by the formula a sub n equals a sub n minus 1 minus 5, where a sub 1 is 12 and n is greater than or equal to 2. It says list the first 5 terms of this sequence. Well, it's not so hard because we know that a sub 1 is 12. They told us that. It's right here. And now if we want to know a sub 2, a sub 2 is equal to a sub 2 minus 1 minus 5. And so what we see is that, well, let me clean this up a little bit. A sub 2 is a sub 1 minus 5. The next term is the old term minus 5. The old term is 12. 12 minus 5 gives us 7. It says do this 5 times, so now I need to know a sub 3. A sub 3 is based on the old term, a sub 2 minus 5. A sub 2 is 7 minus 5 is 2. A sub 4 is based on the old term, which was a sub 3 now, minus 5, and it is negative 3. And if you notice, what we've done is we've subtracted 5 every time. So I think that it's safe to guess that this is going to be negative 8. I hope you see that. It says write an explicit formula. Well, what's happened is this is a recursive formula. Everything we do is a reoccurring event. It's based on the thing that happened before. So explicit formula is where we don't have to know what the item before was. So remember, our starting point is at, well, our first term. Our starting point's at our first term, which is 12. And what we're doing is we're subtracting 5 every time. And we're going to do that once for each space away from the first term that we get after we've done the first term. So that's why the n minus 1. Here's our formula. Then we'll add a little bit of insurance and just make sure that our audience knows that this is for values of n greater than or equal to 1. Find A6 and A100. Well, you could see finding A6 would be pretty easy. We can predict that it's negative 13, but I'm pretty sure most of you don't really want to get all the way to 100, especially not with this process. So let's go ahead and say A sub 6 is 12 minus 5 times 6 minus 1. So this is 12 minus 5 times 5. Our calculation should be saying 12 minus 25. And lo and behold, the negative 13 that we predicted just by subtracting 5. So this is really kind of a nice, quick way, much quicker than the recursive formulas to get somewhere. So then we have a sub 100. Well, I bet you're thinking it's a good thing we have an easier formula for this. 100 minus 1, well, I hope you are. And a sub 100 is 12 minus 5 times 99. 5 times 99 is 495. And then that's going to be subtracted from 12. So a sub 100 is going to be negative 483. We certainly didn't want to go out 100 times trying to find that answer. So it's a good way to do it. All right, one of the most famous sequences is the Fibonacci sequence. 1, 1, 2, 3, 5, 8, etc. And if you're going, it says, how is each term of the sequence generated? Well, if you look here, probably finding the pattern isn't so obvious. But if you look here, it says the new term is the term in front of it plus the term in front of that. If you think about it, if we were to call this n, this would be n minus 1, and this one would be n plus 1. And if we add the two terms, if we want to know n plus 1, the 8, we get it by adding 3 plus 5. So what we did was we added by adding the 2 prior terms. So horrible looking question, not really that hard. Okay, each sequence below gives an explicit formula. Write the first 5 terms of each sequence. Then write a recursive formula for the sequence. So now we're going to go from a really quick way to find things to a hard way. I think what we'll do is we'll test this out. This is 2 times 1 plus 10. So it looks like A sub 1 is 12. And if we start to see a pattern, which I'm sure we will, maybe we will just go ahead and write the following ones. 2 times 2 plus 10. Looks like 4 plus 10 is 14. So it looks like what we're doing is adding 2 each time, but let's go ahead and just verify. A sub 3 is 2 times 3 plus 10, and we got 16. So it looks like our terms are 12, 14, 16, 18, and 20. Now we have to write the recursive formula. So the new term, A sub n plus 1, is the old term plus 2. That's the only thing that we did to get from the old term to the new term. Boy, that looks bad. Let me see. Maybe I'll just settle for underlining there. Okay, good. It's a little more devilish with the 1/2 in here. We're going to start with n equals 1. A1 is 1/2 to the n minus 1. And n was 1, so let's go ahead, 1 minus 1. 1/2 to the 0 power is 1. A2 is 1/2 to the 2 minus 1. And that is 1/2 to the 1, which is 1/2. So we divide it by 2. Let's do one more. A3 is going to be 1/2, and then 3 minus 1. So that's 1/2 quantity squared. And that is 1/4, 1/2 times 1/2. So we see that it's getting a little smaller. Good sequence thinking about 1, 1/2. Half of a half is a quarter. Half of a quarter is an eighth. And half of an eighth is a 16th. Those are our first 5 terms. The recursive formula would be A sub n plus 1 is A sub n times 1/2. The new term will be half of the last one. For each sequence, write either an explicit or a recursive formula. Well, it doesn't really matter too much to me. This one is fairly simple. We can say A sub n plus 1. The new term is the old term, A sub n. It's the opposite of the old term. Real simple. Just flip the sign back and forth. And then this one, when I first looked at it, I was like, I don't know how to do this one. And then I thought about it when I looked at the answer, and I'm like, wow, I feel really silly. So this one here, probably the explicit formula is the easiest thing. And we say A sub n is n over n plus 2. Check it out. 1, 2, add 1. Whatever the numerator is, add 1, and you've got the denominator. Never make life harder than it has to be. Opens a bank account. The deal he makes with his mother is that if he doubles the amount that was in the account at the beginning of each month, by the end of the month, she will add an additional 5 to the account at the end of the month. Let AN represent the amount in the account at the beginning of the nth month. Assume that he does in fact double the amount every month. Write a recursive formula for the amount of money in his account at the beginning of the n plus 1th month. All right, so what we know is that the amount of money in the n plus 1th month must be twice what it was in the month before. And when it is, that his mother will add $5. We have to set the condition n greater than or equal to 1. And we don't know, we don't really have anything else. Okay, what is the least amount he could start with in order to have $300 by the beginning of the 3rd month? Well, this one's a little tricky because what he has to do is he needs to have $300, at least $300, by the third month, by A3. So A3 is based on A2. And it must be twice what A2 was, plus the 5 his mother gave him. The problem here is that we don't know what A2 is. So A2 would have had to be twice A1, plus the 5 his mother would have given him then. So what we're going to do is now we have something with, we know A3 and we want to find A1. Now we really are at a place where with a little bit of snazzy substitution, we should be able to get the answer. So A3 is going to be twice A2, and A2 is twice A1 plus 5. So I put in all of this right here for this A2, and so I still have to add this plus 5. So what we get is, and we want this to be $300. So 300 is the least he can have in there, and then if we distribute, we get 4A1 plus 10 plus 5. 300 is going to be less than or equal to 4A1, the original amount, 4 times A1, I guess we're getting a parenthesis in here, plus 15. I can subtract 15. 285 is going to be less than or equal to 4A1. Divide by 4. And we find out that he had to have had a minimum of $71.25 in the account in order to reach his goal of 300.